I want to make sure you guys know how to do this one because your next quiz, which will probably be Wednesday, pretty much guarantee you will have a question like this on the quiz. So how do you do this one? What has to happen with this 2 here? So the exponent has to go to both of those. So the 2 has to get raised to the second power. The x squared also has to get raised. Whoa. The x squared also has to get raised to the second power. Yes? So 2 squared is 4. What do you do with powers raised to powers? You multiply. So x to the 4th. Times, what has to happen with that 3? It has to get raised to the 3rd power. And the x to the 3rd also has to get raised to the 3rd power. What is 3 to the 3rd power? 27. And then x to the 3rd would be x to the, what do you do with powers raised to powers? You multiply, so that'd be x to the 9th. Am I done? No. What can I do with the 4 and the 27? You times them. No. You times them together. What is 4 times 27? 16? What is 4 times 27? 108? Like, what are you talking about? Okay, 108. And then x to the 13, because you would add those. I can pretty much guarantee you your next quiz will have a question just like that. Okay? Are we good with these? Yes, no, maybe so? What did you guys put on the homework for question 42? What did you put for 42? Anybody? How'd you get that? How do you find the area of a parallelogram? All you do is do the base times the height. So all you had to do was the base, a squared times b, times b to the 3rd. How many a's you got? Well, you got a squared. How many b's do you have? 4 of them. That's it. A squared, b to the 4th. What did you guys put for 39? What would your exponent be there? 8. So the answer is 1 over b to the 8th. What would your exponent, what's the exponent missing in 36? 3. What'd you guys put for 33? Because this is, again, I can guarantee you there will be a question just like this on your next quiz. First of all, is your final answer here going to be positive or negative? Why negative? Because the negative is on the outside, right? It's the 4, the exponent here, and the negative have nothing to do with each other, right? If this parenthesis was on the other side of the negative, what would the final answer be? Positive, because 4 negatives would make it positive. So we know our final answer is going to be negative, so we can pretty much forget about that part for now. What do we have to do with this 4? Raise it to the 4th power. And that one I would use a calculator for. What is 4 times 4 times 4, 4 times, or 4 to the 4th? What is it? 256. And again, my general rule of thumb, as far as should I actually multiply that out, is the final answer going to be insanely large? If it is, leave it as the exponent. If it's not, if it's somewhere around there or less, then I would multiply it out. What do I do with powers raised to powers here? I got to do x to the 3rd to the 4th, which means I have how many x's? 12. Are we good with these? Pretty easy stuff? All right, pass those up. All right, quick review here. What are some of the exponent properties? Cam, you can yell out the window, hi, Mom, if you want.
Oh, is that her new boyfriend?
Wow. Okay. Tommy, give me one exponent property we've learned so far. Give me one of our exponent properties we've learned so far. Any of them. You should have notes on it. Give me one exponent property. Okay, if you have x to the a raised to the b, then you times them. Obviously, these are not going to be in the same order that we did yesterday because you're giving them to me instead of me giving them to you. Give me another one. All right, so if you see a negative exponent, what do you do with negative exponents? You flip them. Okay. All right, if we multiply, if you see x to the a times x to the b, right? Same base. When you're multiplying, we're going to add those together. What's another rule? What do you got, Hunter? X to the 0 power is always going to equal 1. Okay? What's another one? No, we did another one yesterday. I think we did 2 more, didn't we? 3 more? Oh, we had 7. We had 6? Okay. 2 more. What's another one? What were the last ones we did yesterday? If you have multiple things under the same exponent, they both get the exponent. X times x to the a, y to the a. And that works with multiplication as well as division. So if you have x over y raised to the a power, well then, what happens to the x? It gets raised to the a as well as the y gets raised to the a. Okay? These exponent properties are things that you are going to absolutely need for the next few years. As you progress from Algebra 1 to Geometry to Algebra 2 to Trig, whatever, however far you go in math, these exponent properties are absolutely crucial because it's not that you're going to run into these types of problems all the time. It's just that within problems, you will have to be able to simplify in order to solve other problems. These are exponent properties that you will run into and you'll have to be able to use in a lot of different types of questions. These are absolutely crucial for you to know and to be able to use. Okay? It's not that you have to memorize them in this form. It's just that if you ever run into 2x raised to the third power times 4x to the third, or 4x to the fourth, something like that, that's a problem you need to be able to simplify. What do I do over here? Make the 2 to the third, which is going to be 2 times 2 times 2 is 8. This x also has to get raised to the third. So then I get to here, times 4x to the fourth, and I have to be able to multiply. I take the 4 and the 8, I multiply them together, and I get 32. X to the 7th, because then I got to know to add those. Okay? Exponent properties are things that we're going to run into a decent amount of time over and over and over again. Another use of these that we talked about yesterday is to be able to take really, really big numbers and multiply or divide by really, really, really small numbers. And sometimes, I'll bet you there are very few people right now in the room that have a calculator that can handle this. Because your screen's too small. It doesn't have enough spaces for you to type that big of a number in. So what's the easiest way to do that? Huh? Scientific notation. Where would I want the decimal in this number? Between the 1 and the 2. I'd want 1.2 times 10 to the 3, 6, 9, 12, 13. Times, where would I want the decimal in that one? After the 4, so I'd want 4.0 or just 4. Times 10, and I'd move it 1, 2, 3, 4, 5, 6, 7, 8. Would it be positive 8 or negative 8? Negative 8. Now, all I have to do is, what's 1.2 times 4? What's 12 times 4? 48, so that should be 4.8. Times 10, what do I do with the 10 to the third and 10 to the negative 8? Just add those exponents. What is 13 plus a negative 8? Positive 5. And that could be your final answer. Or you could put it back if you needed it to standard form of 1, 2, 3, 4, 5. So 480,000. So it's a way of dealing with really big or really small numbers. One, by putting things in scientific notation. Two, be able to multiply numbers once they're in scientific notation using our properties. Easy stuff? Yes? No? Maybe so? Okay.